In this video, we will discuss the FortiGate's integration with AWS GuardDuty and show how to launch this service. AWS GuardDuty is a service offering infrastructure-level monitoring and filtering of suspicious and malicious activity conducted against your EC2 assets. Its core capabilities are various indicators of compromise and IP blacklisting. Through the FortiGate, these infrastructure filters can be applied to dynamic IPv4 and v6 policies in conjunction with higher level NGFW and UTM features offered on the FortiGate. Let's start by taking a look at how the integration is executed. As GuardDuty is activated on a per region basis, the integrating functions must too be activated in each region. As a best practice, it is recommended to activate GuardDuty in all regions and not just those where services are deployed. There are two templates. The first template is called the main event parser. It's installed in a primary region. And what region is determined to be primary is arbitrary, but most likely will be one that is of most importance to the organization. The main event parser deploys a Lambda function that ultimately pushes discovered GuardDuty objects to all FortiGates, regardless of region. For all other regions, the secondary forwarder is deployed. This simplified Lambda function takes local, that is within the region, GuardDuty findings and forwards the raw JSON data to the main event parser Lambda function. From there, the main event parser Lambda function will parse the GuardDuty findings and push updates to all FortiGates as previously mentioned. There are two variations to the main event parser. The first iteration, and the one that is most convenient, is the default VPC template. The default VPC template uses the native AWS VPC to run the Lambda function. In order for this to work, HTTPS must be enabled from any AWS EIP on the FortiGate, and it's supporting security groups to ensure API calls to the FortiGate can be completed. One important note, GuardDuty must manually be activated in the region. The second version of the main event parser is the local VPC template. In this model, the Lambda function runs in the local VPC. The local VPC template requires reachability to the FortiGates from all local subnets. And AWS best practice recommends that Lambda be run in at least 2 availability zones for survivability. If you are encrypting your environment variables, which is recommended, the local VPC template requires that a KMS endpoint be resident in the VPC. When running the main event parser and the secondary forwarder, there are certain inputs that are required. The first variable is required. The FortiGate login info list contains the credentials for accessing the REST API on FortiGate. Multiple FortiGates can be deployed here by piping between sets of credentials. Make sure that there are no spaces between the parameters and that the usernames have super user access. The key administrator is the username in the AWS account that has permissions to use KMS encryption. The next three, the target Lambda name, target Lambda region, and target Lambda ARN, are given as outputs from the main event parser and should be used as inputs to run any secondary forwarder templates. Some of these variables are sensitive and should be kept confidential, and this is done with KMS. These instructions allow for the IP addresses, usernames, and passwords to remain obfuscated. A user with KMS permissions can decrypt as the example shows. Having completed this overview, let's move on to deploying the templates. The first place we're going to start is at GitHub. Navigate to github.com/Fortinet Solutions and then to AWS CloudFormation Templates, Templates, GuardDuty 5.6. Here's where you'll find a README file that you can peruse with all of the details that we discussed previously. Additionally, in this directory, you'll find your templates for the main event parser, both versions, and the secondary forwarder. Select the default VPC template for the main event parser first. Here we can see some of the default parameters that are assigned to GuardDuty findings in FortiGate. These are prepended to address objects to easily identify those as GuardDuty objects. With our templates copied to a local directory or S3 bucket, we can now deploy in CFT. Here we're just going to give the stack a name. And we have variables that can be set. Make sure you enter your FortiGate login info correctly, as well as your key administrator information In our example, we're just using SDN connector as a username. In the next screen, we'll have to click the checkboxes to allow the CloudFormation template to create requisite IAM resources, as well as transform sets. Shown here are the resources that were created or will be created for the Lambda function. Clicking execute will launch the CloudFormation template. This will take a few minutes to complete. Once completed, take note of the resources that were created and the outputs provided. These outputs will be important as input values for the secondary forwarder template. Next, we launch the secondary forwarder template in CFT. As with before, load your file from a local directory or an S3 bucket. Input a stack name. Enter the variables that were provided as outputs from the prior template. And as with the previous template, we have to give it permissions to create IAM resources. And from there, you can click execute. Once completed, the secondary forwarder template will have deployed the Lambda function in the VPC in which the secondary forwarder was launched. Selecting the resource tab shows us that the resources that we needed for our secondary forwarder were properly created. Our next step will be to activate GuardDuty in each of the respective regions. To start GuardDuty, from your EC2 console, navigate to GuardDuty by typing GuardDuty in your search, selecting GuardDuty. You'll immediately be brought to this Get Started page. Selecting Get Started takes us into the GuardDuty launch page. Selecting Enable GuardDuty will activate the GuardDuty service for this region. From here, we'll see that we're on our findings page. There are currently no findings as we just started the service, but we can generate sample findings by navigating to Settings and clicking Generate Sample Finding. Going back to our findings page, we now see a list of findings that were generated. From here, we can log into our FortiGate. If our Lambda function deployed correctly, we should now see new address objects prepended with GD for GuardDuty listed in our address objects table. And we have multiple types of address objects here. The first are just individual addresses. These are IP addresses or subnets that triggered a GuardDuty finding. That's not that helpful when you need to create a dynamic list. So what's also generated are address groups. And these address groups will continue to aggregate all individual GuardDuty findings based on the category into which they fall. There is an overall catch-all for GuardDuty aggregate events to capture all GuardDuty events. With these address groups created, we can go into our IPv4 policy table. And here we see that we have a GuardDuty policy already created, and this dynamic policy will continue to capture all new GuardDuty source IP addresses. With that overview and GuardDuty functioning correctly and integrated into the FortiGate, that concludes our overview. Thank you for watching.